Welcome back to the deep dive. Today, we're tackling something that, well, when we first saw the source material,
Huh, yeah. I think "holy S" was the exact phrase, wasn't it?
it absolutely was, because we're looking at EMC22's Einstein's equation, but through a completely new lens.
That's right. The core idea, the thesis we're exploring, is that EMC 222s isn't just saying energy and mass are, interchangeable stuff.
No, it's apparently much deeper. It's about coherence
Yeah,
and decoherence.
exactly. It's a statement about how order and disorder, or maybe structure and flow, exchange within the universe's fundamental field.
Okay. So our mission today is to give you a kind of shortcut to this view, seeing mass, energy, maybe even gravity as just different aspects of one single rhythm.
A rhythm of coherence, yeah. How the universe keeps track of its own phase, its own organization.
Right. Let's try and unpack that. We need to strip away the symbols for a moment and redefine them using this coherence idea.
Okay, where do we start? Speed of light.
Yeah, let's start with Stoic.
Okay, so in this framework, $2 isn't just the universe's speed limit. It's way more fundamental. It's the actual rate of perfect coherence.
Perfect coherence.
Yeah, think of it as the baseline rhythm of the vacuum itself. The speed at which perfectly ordered information, perfect phase alignment, travels through space-time.
Okay, so $2 is like the universe's fundamental frequency, the ultimate coherence.
That's a good way to put it, the rate. Now, if that's the rate, we also need something to describe the local degree of coherence, right?
Right.
How ordered a specific patch of space is.
Ah, so there's a variable for that.
Yes. The source material uses a field, let's call it AD, to represent this local degree of coherence, and this is where mass comes in.
Okay, so mass is linked to this A field.
Directly, mass is redefined as the measure of how much that perfect coherence, represented by ST, is disrupted or localized. It measures how far the internal oscillations of a system, this are out of sync with the background field.
Out of sync, like locked in on itself.
Exactly. It's how tightly a system is bound in a kind of self-referential loop, unable to perfectly share phase with the wider universe.
Yeah.
That stuckness is its mass, its inertia.
Wow, okay. That's a very different picture of mass. So what about 8, energy?
Energy is then the total potential of that locked-in pattern, that mass dollar, to unlock, to open up and release its stored structure back into free flow.
So when something decoheres or relaxes?
It releases energy, radiation, motion, whatever. It's releasing that stored phase information, you could say, trying to get back in sync with the baseline coherence.
Okay, let me try and summarize. The equation EMC22 becomes energy equals the amount of coherence disruption, molar times the square of the fundamental coherence rate.
Precisely. It's the universe balancing its books between localized, locked-in coherence mass and open, flowing coherence energy.
And this view, it works perfectly fine in normal situations, right? Like for stable atoms and light.
Absolutely. Yeah. Where EMC2 has always been flawless is when you can treat space-time as smooth and the background coherence rate as effectively constant. And where the local coherence, nemesis, is stable, like a chunk of rock or a steady beam of light.
But this is where it gets really interesting because the sources claim the equation fails so hard elsewhere, and that failure tells us something.
Right. If $2 is tied to coherence, the equation should only start needing corrections when coherence itself becomes dynamic or significantly disturbed.
And the sources mention 3 layers of coherence.
Yes, sort of levels. First,
Right.
perfect coherence, that's the vacuum where COP is truly constant. Second, locally disturbed coherence, that's ordinary matter, where EMC2 works as a really good average.
And the 3rd layer, that's the failure zone.
That's the failure zone. Broken or evolving coherence. Think strong gravity, like near a black hole, or highly entangled quantum states, or maybe the very early universe. In those regimes, the ability of spacetime to transmit coherent phased information in the local value of 2 orders effectively isn't uniform anymore. It's changing.
So the original equation isn't wrong, mathematically speaking, for its domain. It's just incomplete. It doesn't account for situations where the background coherence fabric is itself changing or stressed.
Exactly. It's missing a term that tracks the energy stored or released purely because the degree of coherence itself is changing.
Like an energy cost for becoming more or less coherent.
Precisely. So the conceptual correction looks something like 1A truncal 2 plus delta eco. That extra bit, delta eco, accounts for the energy tied up in the changing coherence field. 1x maybe its potential energy, or energy stored in its gradients, its interfaces.
And when that coherent field is stable or uniform,
that delta eco term just vanishes, and boom, you get Einstein's equation back. Perfect.
okay, this feels big. If mass is about phase misalignment with the background field, This sounds familiar, doesn't it? Like echoes of other ideas in
Oh,
physics,
absolutely. It potentially ties together several threads that felt disconnected. Think about the Higgs mechanism.
where particles get mass by interacting with the Higgs field.
Right. Conceptually, that's very similar to saying mass arises from a kind of phase misalignment and interaction with a background field, in this case, the coherence field. A textile,
And what about things like zero-point energy?
same potential connection. Some models propose inertia, which is mass, comes from interaction with the vacuum field's fluctuations, which are inherently coherent. This coherence view provides a single potentially measurable field that could underlie both phenomena.
Okay, so if this framework links these ideas, maybe it can tackle the really big problems. The source material claims this view uncovers almost everything we've been missing. That's a huge claim, especially for, say, quantum mechanics and gravity not playing nicely together.
Well, that's the hope, right? It potentially bridges that gap by saying geometry and quantum waves aren't separate things. They're both just aspects of this underlying process of phase ordering.
How does that help with quantum weirdness? Entanglement, wave-particle duality.
In this view, those are just different manifestations of shared or localized coherence. Entanglement is like a persistent, non-local coherence link between systems. Wave-particle duality. The wave is the spread-out coherence field, the probability. When that coherence collapses locally, snap, its energy density spikes, and you perceive a particle.
Okay, and gravity. If mass is localized decoherence, how does that cause gravity?
Gravity stops being a fundamental force you add on top. Instead, it is the geometry that naturally emerges when you have gradients and coherence. Changes in the fields from place to place literally bend the fabric of space-time.
So the decoherence, the mass, source of the gradient in the A field, and the gradient is the curvature.
You got it. The mass isn't the direct source in the old sense. It's the source of the coherence disturbance, which then manifests as space-time curvature.
Wait, hold on. General relativity works perfectly in our solar system, like incredibly well tested. You're saying there's this whole other coherence field bending space, but its effects, these delta eco terms, just conveniently disappear exactly where we can measure things precisely. How?
Ah, yes, the chameleon mechanism.
Yeah.
This is maybe the most elegant part. The mathematics suggest that in high-density environments like near the sun, near Earth, the coherence field gets sort of saturated. Its value settles down to be extremely small and almost constant.
It hides itself.
It effectively decouples, yes.
Hmm.
When Agonatex is nearly constant, its gradients are tiny, its potential energy contribution is minimal. So those extra terms that would modify general relativity, the delta eco, they naturally become negligible precisely in the strong gravity high-density regions where GR is tested.
Okay, that is clever. It hides where we look hardest, which implies it doesn't hide where gravity is weak and things are spread out, like galaxies.
Exactly. And that's where dark matter and dark energy come in. They stop being mysterious separate substances.
They become what? Fingerprints of this coherence field.
Precisely. On the largest scales, the smooth background potential energy of the coherence field itself, the aviator term, could act like dark energy, driving cosmic expansion.
And dark matter, the stuff holding galaxies together.
That could be the energy stored in the gradients of the coherence field, the nobla at 22 term, where the coherence changes across space like in a galactic halo. That gradient energy contributes to the overall geometric pull, mimicking dark matter without needing any extra particles.
Holy S. Great. If that holds, coherence creates structure. Structure stores energy. Energy flows to restore coherence. It's one loop.
It's a potentially unified picture. And the crucial part is, this isn't just hand-waving philosophy. It's built on standard maths, scalar-tensor theories, and it makes concrete, testable predictions.
Testable. Okay, let's get practical. How do you prove this? We need to see how gravity actually responds to this field. You mentioned the source term for gravity changes. It's not just mass density anymore.
Correct. Instead of just using matter density to curve space-time, gravity responds to an effective density, let's call it N. This includes the normal matter density, but it's modified by the coherence field and its gradients.
Modified how? There must be constants involved, right? Coupling strength.
Exactly. Two key constants emerge. First, there's alpha, which tells us how strongly the local coherence state modulates the gravitational effect of ordinary mass, like how much the weight of matter changes based on local coherence.
Okay, that's alpha. What's the second one?
The second one, let's call it D'Amelio 22, measures how much energy is stored in the interfaces or gradients of the coherence field, the nobla A2 part. This is the part that might mimic dark matter.
And the critical test, these constants, alpha and delta LDO, they have to be the same everywhere. Lab bench, distant galaxy, same numbers.
That's the make or break point. They must be universal constants. If you have to tweak them for every different galaxy, the theory fails.
Right. So, step one, measure them here on Earth. The laboratory closure test. How do you actually do that?
It sounds conceptually clean, though technically challenging, I'm sure. You need a setup where you can actively drive changes in coherence, delta, inside some material, maybe a special fluid or a resonator.
Okay, you make the coherence wiggle. Then what?
You put that whole system on an incredibly sensitive scale, a precision balance.
Yeah.
If changing the internal coherence delta actually changes how the system interacts gravitationally, you should measure a tiny change in weight, delta WA.
And that weight change should be directly proportional to the coherence change. Delta WW delta.
Exactly. That experiment directly measures your alpha delta. A related experiment, maybe looking at static forces near sharp coherence boundaries, could isolate delta TOE2.
Okay, let's say you do that. You get numbers for alpha delta tori 2. Solid numbers measured in the lab. Then you take those numbers.
Galaxy dynamics test. And you are not allowed to change them.
Right. Fixed constants. What do you do with them?
You pick a galaxy. You map out its normal matter, the stars and gas. Then, using independent observations, things like how orderly the stars are moving, maybe magnetic field alignments, you infer a map of the coherence field across that galaxy.
So you have AR, and you have your lag-measured alpha and beta.
Now, you calculate that effective density using the formula that include A12A, the gradient nabla A22, and your fixed constants alpha and beta 2.
And then you predict what?
You predict how that galaxy should rotate based on the gravity generated by R, and you predict how it should bend light passing nearby gravitational lensing.
Ah, the two big tests for dark matter. Rotation curves and lensing.
Exactly. And here's the killer constraint. If that single inferred map of AR combined with the single set of lab-measured constants simultaneously explains both the observed rotation curve and the observed lensing profile.
Then you've done it. You've replaced two fudge factors, dark matter and dark energy, with one measurable field whose properties were determined independently on Earth.
That would be, well, revolutionary doesn't quite cover it. It would be finding the missing piece that connects gravity, quantum fields, and cosmology.
It ties it all together. Einstein unified space and time, quantum mechanics unified energy and probability waves.
And this coherence view potentially unifies geometry and waves into one continuous process. The universe constantly adjusting its own internal phase relationships.
It really does shift the perspective, doesn't it? From a universe of separate things interacting via forces to a single self-organizing field where structure and flow are constantly balancing.
And if that's the fundamental reality, think about technologies that manipulate coherence. We already are with quantum computing, but maybe precise engineering of this kind of field, that could be tapping into something incredibly basic.
Mastering the fabric itself.
Maybe. And that leaves us with a final thought, something for you to chew on. If mass and energy are just different phases of this universal coherence rhythm.
Like the inhale and exhale of the cosmos.
Something like that.
Yeah.
And if living systems, as the sources suggest, are self-sustaining pockets of high coherence, what does that imply?
About life. About consciousness.
Yeah. If the universe fundamentally operates by managing phase order, by maintaining coherence against decoherence, could consciousness be the most sophisticated example of that process we know? The universe, locally, becoming highly aware of its own phase state, trying to maintain its organization.
Wow. That's definitely something to think about. Is consciousness the universe tuning itself? Okay, that's our deep dive for today. A lot to process there.
Fundamental rethinking of RMC 212. It's certainly provocative.
Absolutely. We'll be back next time with another exploration. Thanks for joining us.